NASA astronaut Don Pettit said SpaceX Dragon windows are stronger and safer than anything NASA ever flew. But how did SpaceX beat NASA's 50 years of experience? They stole the design from airplane windows. While NASA used heavy glass that cracked under pressure, SpaceX copied aviation's oval shape and switched to lightweight plastic. The result? Dragon survived 8 G-forces during emergency re-entry and built the largest space window ever. 2,000 square inches of pure Earth view. But why did NASA miss this simple solution for decades? And what other aviation secrets did SpaceX steal to revolutionize space travel? Let's dive right in. The fatal flaw that NASA ignored. It's 1954. A brand new British airliner called the de Havilland Comet is cruising at 500 miles per hour. Passengers are mesmerized by those massive rectangular windows, offering breathtaking views of the world below. Then, mid-flight, the plane literally tears itself apart. 29 people gone. Instantly. The killer? Those beautiful rectangular windows. Every sharp 90-degree corner became a stress bomb, weakening the metal each time the cabin pressurized and depressurized. After 3 crashes, investigators finally uncovered the deadly truth. Square corners? Kill. But here's the part that'll shock you. NASA knew this. They witnessed the comet disasters. They understood stress concentration better than anyone. Yet for the next 50 years, they kept designing spacecraft windows with the same fatal flaw. Why would NASA ignore a lesson literally written in blood? The answer reveals everything about why SpaceX didn't just beat NASA, they demolished them. The Columbia wake-up call that changed everything. February 1st, 2003, Space Shuttle Columbia is screaming through Earth's atmosphere at 17,000 miles per hour. 7 astronauts inside, just 16 minutes from home. Then, catastrophe. Columbia disintegrates. Everyone dies. But during the investigation, engineers discovered something that would haunt NASA forever. The simple, acrylic plastic windows on Columbia's hatches survived the catastrophic re-entry better than all of NASA's advanced glass and aluminum materials. Let that sink in. While NASA's cutting-edge technology failed, basic plastic held strong. This should have been NASA's wake-up call. This should have changed everything. It didn't, at least, not for NASA. But someone else was paying attention. Someone who would turn this tragic lesson into the most revolutionary spacecraft windows ever built. The 8 G-force test that proved SpaceX right. Meanwhile, astronaut Don Pettit was living through his own window nightmare. 2003, his Russian Soyuz capsule's returning to Earth when everything goes wrong. A guidance malfunction sends the spacecraft tumbling off its planned trajectory. Instead of a smooth 4 G-force landing, Pettit endures over 8 Gs. 8 times his body weight, crushing down on every bone, every organ. Most fighter pilots black out at 5 Gs. At 8 Gs, your body starts shutting down. But those windows, they held. They had to, because at those crushing forces, any window failure means instant death. Pettit would later say something that became SpaceX's design Bible. The oval shape distributes stress evenly, especially during intense moments like launch and re-entry. Oval shapes, stress distribution, aviation principles. SpaceX was listening, NASA wasn't. And this difference in philosophy would soon cost NASA hundreds of millions of dollars. The genius who steals versus the expert who copies. Pablo Picasso once said something that explains why SpaceX crushed NASA. Good artists copy, great artists steal. What's the difference? A good artist copies the surface. They see airplane windows and think, let's make spacecraft windows look like that. A great artist steals the essence. They understand why airplane windows work and transform that principle into something revolutionary. Elon Musk is a great artist in engineering. While NASA kept copying their own past successes using the same rectangular window designs that had been killing people since 1954, SpaceX was stealing the deeper wisdom. They didn't just copy airplane windows. They stole the principle behind them. Oval shapes eliminate stress concentration points that cause catastrophic failures. But here's where it gets expensive, really expensive. The $100 million. Weight disaster, NASA's space shuttle windows were engineering marvels. And financial disasters. Each window system used tempered aluminum glass with thick, multi-layered designs. Beautiful, complex, and incredibly heavy. How heavy? Here's the number that'll make your jaw drop. SpaceX's plastic windows weigh 75% less than NASA's glass equivalents. 75% less. In space, every single pound costs about $10,000 to launch. Do the math on NASA's window weight penalty. We're talking tens of millions of dollars, literally thrown away on unnecessarily heavy windows. But weight wasn't even the worst part. Those thick glass layers made the windows brittle, prone to hidden microfractures that could develop over time in space's brutal environment. SpaceX looked at NASA's approach and asked the question that changed everything. What if we're solving the completely wrong problem? The answer would revolutionize space travel. The egg that cracked. NASA's design philosophy. Want to understand why SpaceX's oval windows are pure genius? Take a raw egg, squeeze it from the sides as hard as you can. It won't break. Now squeeze it from the pointed ends. It'll shatter immediately. The oval shape naturally distributes force evenly across the entire surface. No stress concentration points, no failure zones where cracks can start. This is exactly what happens during launch and re-entry. Spacecraft experience massive pressure changes, thermal stress that would melt steel, vibration that would shake a building apart. Square corners concentrate all that punishment into tiny weak points. But oval windows? They spread the stress like ripples across a pond. SpaceX didn't invent this principle. They stole it from millions of years of evolution, and NASA completely missed it. The plastic revolution NASA refused to join after Columbia's investigation proved that plastic outperformed glass during re-entry. You'd think NASA would immediately switch materials, right? Wrong. NASA's Orion spacecraft still uses a complex mixture of acrylic for pressure resistance and glass for thermal protection. It's like they learned half the lesson, then gave up. SpaceX went all in on advanced plastics. Not just any plastic, but specially engineered acrylic and polycarbonate materials that could handle temperatures hot enough to melt copper, resist impacts from space debris traveling at bullet speeds, and maintain perfect optical clarity in the vacuum of space. The result? Dragon's windows are lighter, stronger, and safer than anything NASA ever built. But SpaceX wasn't done. They were about to create something that would make every NASA window look like a tiny porthole. The impossible window that broke every rule. SpaceX announces something that makes aerospace engineers everywhere say, "That's impossible." For the Inspiration 4 mission, they're removing Dragon's docking port and replacing it with a massive dome-shaped window. How massive? Nearly 2,000 square inches of pure, uninterrupted space view, the largest single window ever flown in space. Engineers call it insane. The bigger the window, the exponentially more stress it has to resist. It's like the difference between holding a dinner plate in a hurricane versus holding up a car windshield. Yet SpaceX made it work, using those same stolen aviation principles, oval shapes, advanced plastics, and perfect stress distribution. The cupola offers passengers a complete 360-degree view of Earth and space. When you're floating weightless inside, looking down at our blue marble spinning below, it's not just a window, it's a portal to infinity. But windows were just the beginning of SpaceX's aviation theft. The parachute secret that saves lives. Most people think parachutes are simple. Pull a cord, parachute opens, float down safely. But spacecraft parachutes face challenges that would terrify any pilot. Dragon weighs 13,000 pounds. It's traveling thousands of miles per hour when those parachutes deploy. The forces involved could rip apart a building. SpaceX's solution? Steal from small aircraft again. The Cirrus SR-22 has a whole aircraft parachute system. If the engine fails or the pilot becomes unconscious, one lever deploys a massive parachute that brings the entire plane down safely. SpaceX took this concept and engineered it for something 50 times heavier, traveling 100 times faster. Dragon uses 4 main parachutes, plus stabilizing drogue chutes. But here's the terrifying part. If even one main parachute fails, the crew dies. That's why what happened in 2023 sent shockwaves through SpaceX. The $2.2 million panic buy that revealed everything. Pioneer Aerospace Dragon's critical parachute supplier files for bankruptcy. SpaceX's response? Immediate panic. They paid $2.2 million to buy the entire company. Instantly. This wasn't just a business deal. This was survival. As NASA's Phil McAllister admitted, we thought, we've done parachutes during Apollo. How hard could it be? It turned out, it could be very, very hard. The Apollo-era parachute knowledge was 50 years old and poorly documented. The industrial base for spacecraft parachutes had essentially disappeared. Both SpaceX and Boeing struggled with parachute development, suffering test failures, delays, and near disasters. Even after Dragon entered service, there were incidents where parachutes opened seconds later than expected. Those seconds could mean the difference between life and death. By acquiring Pioneer, SpaceX ensured they'd never be held hostage by supply chain failures again. But it revealed something deeper about the aerospace industry's fragility. The aerodynamic advantage NASA never understood. Look at Dragon's sleek, curved exterior. Every surface flows like liquid mercury. This isn't just about looking cool. Early spacecraft were designed for the vacuum of space. Aerodynamics? Who cares? There's no air in space, right? Wrong. Dead wrong. Dragon spends critical minutes flying through Earth's atmosphere during both launch and re-entry. Those minutes determine mission success or catastrophic failure. SpaceX applied commercial aviation principles to create a spacecraft that's efficient in both environments. The smooth curves don't just reduce drag, they distribute aerodynamic forces evenly across the entire hull. No hot spots, no structural weak points, no unexpected failure modes. It's the oval window principle applied to the entire spacecraft. But here's the question that haunts the aerospace industry. If these aviation solutions were so obvious, why did it take a private company to implement them? The prison of expertise. NASA had access to the same aviation research. They witnessed the same disasters. They had decades more experience and billions more in funding. Yet they missed solutions hiding in plain sight. The answer reveals something profound about innovation. Sometimes, expertise becomes a prison. When you're the world's leading expert on spacecraft windows, it's nearly impossible to admit that airplane designers solved your problem 70 years ago. Your reputation is built on being the best. Your funding depends on being irreplaceable. Admitting that simple aviation principles could revolutionize your field, that's career suicide. SpaceX had no such baggage. They approached spacecraft design with fresh eyes, willing to steal brilliant ideas from anywhere. But there's an even bigger question lurking here, one that should terrify every established aerospace company. What other obvious solutions is the industry still missing? What other billion-dollar problems could be solved by looking outside the traditional aerospace bubble? SpaceX proved that the biggest breakthroughs don't come from incremental improvements to existing designs. They come from asking, what if everything we think we know is wrong? And that question changes everything. So here's what SpaceX really taught us. Innovation doesn't come from being the smartest person in the room. It comes from being brave enough to look outside your room entirely. While NASA was trapped by 50 years of, that's how we've always done it, SpaceX was busy stealing brilliant solutions from airplanes, cars, even nature itself. Oval windows, lightweight plastics, aviation aerodynamics. These weren't space-age breakthroughs, they were old ideas, waiting for someone bold enough to use them. But here's the question that keeps me up at night. If SpaceX revolutionized space travel by borrowing from aviation, what other industries are sitting on solutions to tomorrow's biggest problems? What if the cure for traffic comes from studying ant colonies? What if renewable energy breakthrough is hiding in whale migration patterns? What if the next computing revolution is inspired by how trees share information? The universe is full of answers. Most of us are just asking the wrong questions. What problem are you trying to solve? And where's the last place you'd think to look for the answer? Let me know in the comments, and if you're ready to see more industries get turned upside down, hit that subscribe button. Because at Space Corps, we're just getting started. The revolution is everywhere.